Hello, welcome to Point On Studio. My name is Jungho Park. Today I'm going to show how we can actually generate analytical model out of IFC model. So last time in the video I showed using Revit model with RhinoInside, we could generate analytical model for SOFiSTiK calculation. And I was thinking, okay, Revit, if we can filter all Revit parameter and geometry with RhinoInside, which means actually we can use any IFC model from different BIM offering software by linking these IFC model in Revit. And we can use, because when you link or import IFC model in Revit, then we can use this element as most of elements, they are classified as IFC class, so we can actually filter the geometry or parameter to use this information with RhinoInside in order to do the same steps, like we can filter the geometry, and then with a script we can generate automatically the analytical model. I think this is huge game changer, and I was not expecting it works so good, but now I just realized it's really amazing, and it's I would say it's huge potential. So because a lot of case when we just link structural model from different software in Revit, we cannot actually enable this geometry as analytical model. So most of case structural engineers have to redraw in Revit, and then they have to do some tedious work for analytical model in Revit. But now this RhinoInside opens completely new workflow. So let's have a look at what it can do, and I'm very excited for this workflow to introduce. And yeah, let's get started. So I created IFC model using Rhino with Visual Arc. So Visual Arc is the Rhino plugin which allows us to distribute attribute in Rhino block elements. So we can use Rhino blocks as a BIM element, which is great because as you can see here, I select the wall and you can see the attribute of as close to BIM authoring software. And I was very impressed by this BIM function in Visual Arc, because these elements we can export as IFC. So I made just simple concrete structure here, and I export as IFC file. And when I check this model in Solibri, as you can see, we have correct building story, IFC building story structure. And when we click on element, you can see the property, especially this IFC properties, which shows IFC types and entities. And in Visual Arc, you can also generate your, let's say, ID. So in Revit, we have Revit ID. In Visual Arc, you can customize your ID to put in IFC information and any kind of like base quantities and etc. So this IFC model, I was actually linking and bind it in Revit. So it becomes like, for instance, wall, they are direct shape of the Revit, but still it shows all these IFC class parameters and extra parameters from Visual Arc. So if let's imagine not only Visual Arc, any software, let's say ArchiCAD or Allplan, Namescheck's Allplan, or any other like Bentley, Open Building Designer, and etc. Any other BIM software, they have ability to export IFC, and using RhinoInside now we can link and bind this IFC model and we can filter this element. I'm very excited now. So I'm just going to open Grasshopper from RhinoInside, and Rhino also. So as you can see, it's already generated this analytical model automatically. So when I turn on the preview, these are the geometry that we basically got it from the the IFC model, and same as previous videos. It's just if you look at this analytical model, they are in the middle of slab. You see the blue indicating the analytical surface of the slab, and also the wall you can see here is in the middle, and they are extended to meet the analytical surface of the floor, and that goes same to columns. Yeah, it's working perfectly. So let's have a look at the script. Script is very simple, just same as last video that we use Revit elements to convert as an analytical model. Apart from RhinoInside part, so when you look at here, let me bring this glass utility so you can see actual component name. So this parameter key, first of all, I'm going to filter wall elements. So using parameter key component, what you can do is we can filter what parameter we want to see from our IFC model. So I specify here the key parameter is called Ifc Export Edge. So Export Edge parameter is when you link Revit, IFC model in Revit, you will be able to see any imported IFC has this special parameter called Ifc Export Edge, which means this Ifc Export Edge, via the BIM authoring software, they exporting the IFC class as IFC column type, and it specifies the enumeration of the column type. So we have this information that we can filter from Revit. For instance, if I click on the slab, and as you can see, we have here export as IFC slab type, and then we have floor. So this is like very structured data information that is so to say information that you can filter. And what is could be interesting is that let me think. Yeah, for instance, this even though in Revit it shows as a floor, but unlikely these imported IFC file we cannot mark on the structure, and we cannot mark as enable analytical model. You remember, if you have normal Revit wall or floor, which we draw as a structural floor, I'll just quickly draw in here. Then here it has property called enable analytical model, which means when we see analytical model here, you see this surface which is in belong to physical slab of Revit element, but the IFC import slab, they don't have this function. That's why this workflow is very interesting. So now I'm going back to RhinoInside. Let's open Grasshopper and also Rhino on the left side. So we get this IFC Export Edge parameter that we can filter equals rule. This is also one of the components you can see from Revit on the filter, and we have this rule that we can define. So we're going to filter IFC wall type standard, that we can use this parameter filter. So this is the rule for the filter, and then there is a RhinoInside has this parameter filter component on the filter, and this component. This filter allows us to now get all these Revit elements that has this parameter name, and we can use this as a document element. Okay, so we get all the, because wall, when you import IFC model in Revit, they becomes direct shape. So that's the reason why we cannot use just ordinary the input the parameter type or component family because we cannot use them. But by using this filter, we can filter that element, and we can get element parameter, which means you see here I want to distinguish between core wall and exterior wall by specifying the IFC tag. So in BIM authoring software, in this case Visual Arc in Rhino, I specify this tag name specifically for the core wall, say C1, and exterior wall I put X1 as a value. So in Revit, when you import the IFC module, you can see here IFC tag parameter is remaining there, so we can filter that value in RhinoInside. So going back to RhinoInside now, so we're gonna get the element parameter of IFC tag. So it's a case sensitive, so we have to follow the exact spelling of the parameter, and of course there will be some like repeating. About 28 elements has this parameter value, parameter, and that we can create set. So we know we have C1 and X1, so we have two of them that I'm going to separate them by using list item. And then this list item output, we can go again equal rule to again filter this parameter. So IFC tag, we can provide the value of C1 or X1 to distinguish between core wall and exterior wall. So this filtered parameter going to be used for element filter. So we're going to, our element here 28 instance, the wall the wall direct shape interact. You see, if I put the panel here, this is indeed a direct shape, and we have this type of direct shapes as a wall, and I'm going to use this element using parameter filter. So we will have like a boolean information, and eventually we can filter if it's core walls or exterior walls. This is already awesome because you know, which means we can use any IFC model to use in RhinoInside. And once you filter it, we can now convert this element to Grasshopper geometry using this component. This component is under Revit, and below element we have element geometry. As a default, the level of detail is already seems like providing as coarse fill in Revit. So you have here coarse or medium or fine, but it looks like as a default it's already provided by RhinoInside. But otherwise you can also set level of detail level, and here you can, from the drop down menu, you can define which level of detail you want to generate as a geometry. For now I'm gonna skip because it still works as a coarse fill. And now we're going to, what is interesting for me is that this element geometry from the direct shape, as you can see here, we have bottom center line of the wall as a curve geometry. So if I put the panel here, then let's have a look. We can see we have direct shapes, but here doesn't show. But when I convert to element geometry, we will see here we have closed B-rep and also line-like curves. So every instance of B-rep, they have a line-like curve from the center of the wall, which is awesome because we can use this, we can use this curve line to extrude analytical model. So what I'm doing here, I'm going to take the index of 1 to filter the curve line of the wall geometry, and we just do some operation here, move it to the floor height because the analytical surface of floor is in the middle of the slab geometry, and you just offset, and then we can extrude it. So we have like this analytical surface which going to meet in the middle of slab and also perfectly enclosed. So there is no opening right now, but we're going to provide openings with other solution. So that's how I can come up with this analytical wall part. And let's have a look. The other part, for example, we can use document category picker. We're gonna generate generic models. The reason why is when we import IFC model in Revit, all the openings, they are converting to IFC opening element, but at the same time they belong to Revit generic model category. That's the reason why I'm here the filtering generic model. And if I isolate slab here, even though in native model we don't have here specifically the opening geometry, because of IFC has it recognized from the IFC format, these openings you will generate IFC opening element in IFC format. So that's why here we have also generic model in middle of the slab as an IFC opening element, but you can filter them. So I'm going to show you here in RhinoInside, back in RhinoInside. Same step, we're going to this time element category filter, and we convert this category as a the elements here, Grasshopper elements, and then we generating geometry using the element geometry component here. So we have all the wall openings and then floor openings, but we're gonna use wall openings to subtract any analytical surface of the you remember here we have sorry, we extruded here. We have this plane extrusions, and we're going to use the openings to subtract openings of analytical model. So that's why here we have this generic models, and these generic models we're going to just filter the volume size to because we don't need this floor opening to subtract. We just need wall openings to subtract from floor surface. So here we have them already filtered, and this one we just use it as a subtract component. So between our analytical surface by using split BREP nodes, and then we filter the area, and that's how we can get the eventually we can color patterns, and it's always the same repeating script here. Sorry, it's a components here, and you can display between with wall openings or without wall openings from this value list. Alright, so that part we've done, and column is also flow is same. We can use document category filter, and we can do same step, and we already filter the floor, and floor is super easy to generate analytical model. So there's nothing surprise. So you just deconstruct BREP, and then you sort the area, and you filter. You get the middle point, and you move with a 2 vector line between this line, and you generate middle slab position, sorry, center position. Of course this you can define later if it's top or center, but we'll skip that. You have here now slab, and here it shows slab just because I draw the Revit slab. Somehow it isn't. Let me recompute. So recompute is refreshing your script with RhinoInside. So now if you look, it brings only the slab we have from IFC model instead of Revit elements. Alright, so we have slab is done, and then we have structural columns. Same, we can filter from category, and then this time, if you look at IFC model, they all has this special parameter called IFC special container. So for example, this column has special container level 2 and level 1 and level 0. This is like coming from IFC building story and class, the class name. So you can see we have this building story structure in any IFC BIM software, and these elements belong to each building story. That's how we can bring in Solibri, for example, which story these elements belong to. Now in RhinoInside we can sorry about that. So we can filter this special parameter for columns, and when you make a set, we can see right now for the column elements we have 0, 1, 2 is defined, and I'm just filtering again the parameter for IFC special container that bring it's same step always. We filter and then we can use curve patterns, so we can distinguish each level of columns. Then we convert it to Grasshopper preview. And this script is obviously same as other scripts, so we just deconstruct VREP, and then we're going to filter only the bottom and top surface. We'll find the center point of that, and we're gonna connect them as a analytical line. But this line we need to scale based on center point, and we want to find an intersection point between the floor slab and this column, and then we shatter. So we will find the closest point on curve to get the parameter of this point location, and then we just shatter the curve, and we just filter we don't have slanted column, but we filter only straight column that split it by the parameter, and then we get the list item of them, that eventually we get all these columns, that is analytical column, which meet with exact plane at the floor, analytical slab, so which is very important. And that's it pretty much. So once you've done, we get this analytical model, and so analytical model is already perfect in here. So what I can do is now I'm going to enable SOFiSTiK components. So we connect the slab in foundation slab. The foundation slab here, I'm going to provide bedding condition, so we don't have to define area support condition for this slab. And all the other slabs, I'm going to give thickness of the IFC parameter, and we can take a look all these things. And right now it's from my previous script, so I don't want to define the wind road. I just want to do dead road for this case. So all columns lines are converting to the column, and you can see all the group number, and so everything is same. Only what I need here, because I don't want to use wind road in this example, I just use dead road. So we define the ID, first ID is dead road, and we don't specify the type, and the you can see this face, we put 1 as for the dead road, and I'm going to put the title as a dead road here. If you define live load or other load cases, then we can provide here for the fact, here we can provide 0, because only dead road we need 1 as a parameter value. and that connecting to SOFiROAD, and we assemble all analytical model in our assemble here SOFiMesh component. And this data we're going to enable, so the entire script now baked to the TEDdy file. So it's convert to TEDdy file, and let me this definition we specify in existing CAD file. Sorry, the TEDdy file .dat file format. And now I'm going to open so now I'm just going to open the SSD file to see this calculation. And here we have the result to see the dead load. You can see right now the dead load is impact on the roof area, this cantilevered roof, because the other part is quite stable, as you can see. I'm just gonna make the slab thin line here, so there is almost no impact on the structure here, and the roof is quite weak, you can see from this view. So by referencing here, I want to modify the IFC model, original IFC model, and then we can calculate a bit better result. So let's go back to Visual Arc. I'm going to copy this column from both sides here, and just simple Rhino command and V to copy. Grid snap. So we're gonna snap the endpoint, and I've copied it there. Just to make it a little bit more fun, I'm going to move this geometry randomly. I don't know. Let's say something like this. Yeah, this is what I love about Rhino and Visual Arc, by the way, because you have such a freedom to move it around, because even to do this sort of operation, copy and move it around from Revit or other software, it's first of all very slow to modify, and you have to think about all the constraints of the elements, which is annoying because you end up like, oh my god. But in Rhino environment, you have such a freedom to modify these elements without any difficulties. So that's what I love about Rhino and Visual Arc, because for the initial conceptual stage, it's so much faster and better than any other BIM software, let's say. So I modified this sort of position, and maybe I'll modify also a bit of the here opening position, just to distinguish the difference between the new model and old model. So you may see. Okay, I think that's kind of good enough to demonstrate the amendment. Now I'm going to export this model once more as IFC model, and let me say here from IFC end. So I'm going to export, and before linking to Revit, I usually use Solibri Anywhere. Is one of the free IFC viewer, and because I found it's the best, one of the best, and easy to use it. You can use any other IFC viewer. So the level is correct, looks like correctly assigned, and all geometry for me looks good how I modified. So you can see the entity, the class name, they are all matching. So to me that looks proper to now link into Revit. I'm gonna bring here my Revit file, and let me save this file another name, save as instead of start, I'll make it to end. I'm just gonna save it. So what I'll do, I'll leave the levels as it is because the level structure is same as previous model, and I'm going to delete. Maybe instead of deleting, I'm gonna put them all on the existing phase in Revit. Actually, I never tried it. Let's see. And what I'm going to filter the phase. So I'm going to show new and show new only. So we hide existing phase, let's say. And I'm going to link now the IFC model we exported from the RhinoInside. Excuse me. The end. So let's see, when I link now, the reason why I'm not importing IFC directly in Revit is that sometimes Revit doesn't like to import directly the IFC format. So it's better to link first to see if everything is correctly linked. Then after that I usually bind it. So I bind, but the level and grid I'm not gonna copy it because they are same as previous model. So only the geometry I'm going to bind into the Revit model, and I'm going to remove the IFC link. So there is like a model group in Revit, and I'm going to ungroup the model group. So we have this amendment. Let me put the shade so you can see. So you can see the changes, right, from the visual art. So when I click, all the parameters should be there, as you can see, and the wall parameter also should be remain as it was, like the IFC tags and etc. So now when I go back to RhinoInside, let's put it on. Where is it? RhinoInside. Sometimes cannot find it. Alright, here I found RhinoInside. The Grasshopper is SOFiSTiK. Okay, maximize. Oh, right, here we go. And because the geometry updates, let me turn off the SOFiSTiK part. And what I'll do, I'm going to recompute. So in RhinoInside, we'll get the, hopefully nothing's happened. Alright, something is not working. So slabs are working, and structural columns, they should have all these parameters, same parameter. IFC special container, yeah, it is true. Let me recompute once more. Recompute. Something is funny when so it's funny because it should work, because let me see the panel. These tags are filtered, okay, after 28 instance, 29th item there is no okay, that's probably this yeah, the phase solution might not work for this script. So let me go and show only existing element here. I'm gonna delete the old model, and I'm going to show only new phase, which is new, and I'm going to recompute. Let's see what's gonna happen. So alright, so the here, how come it's all nothing? Bring it here. Let me filter the elements. There we go. And the IFC tag of this direct shape, they are IFC tag, they have information. Let me recompute one more time. Okay, and back to Grasshopper. Alright, the elements came and we could filter. When I did element filter, all of them has null. Alright, I may close completely this Revit file and then open it again, and let's see if this script works or not. Probably, I don't know, some memory issue. Let's see. Let me pause the video. Alright, I found out the problem because it's not the Grasshopper side of problem. You can see here we have the these parameter filter. It didn't work because we obviously have IFC tag parameter from the new imported the IFC model. Here we have IFC tag, but some reason when I import new elements, these are basically project parameter from Revit. Project parameter is a special one that you could define these parameter from Revit specifically, and some reason because of the new IFC link and import, the same name of project parameter was duplicated. So as you can see here, when I click on this word direct shape from IFC module, there is duplicated same name of IFC parameters. So that's the reason why Grasshopper is mucking around to find the parameter name. So the solution I could imagine is, unfortunately we cannot use the same Revit model from previous one. So I'm gonna close the entire Grasshopper and RhinoInside, and I have to open new complete new Revit project file, so we don't have to have duplicated parameter. So let me open new Revit project Revit application, and we have to set completely new project. Maybe I'll find a better solution in the future, but for now it seems like when I relink new IFC module, all the project parameter it seems to be duplicated. So let's see, I'm going to open new, and I'm gonna use structural analysis template, metric template. And before I link the IFC model, I want to also check my project parameter, project unit in Revit. I want to make sure this is meter. So when I put on later for SOFiSTiK, for with RhinoInside, we can have common Rhino unit. I mean, obviously we can convert between Rhino unit within RhinoInside, but I just don't want to have this tedious extra work in Rhino. So let's see now, it's completely new Revit file. I'm going to add in, click on RhinoInside, add in button. And we're gonna, okay, once RhinoInside is open, I'm going to click on Grasshopper part and also Rhino preview here. So we have same setting. And in this Revit model, I'm gonna delete level 2 here, what it's given. Yeah. And let's link new IFC model from the new export, and Alright, so I'm linking this new IFC model, and we're going to bind it with this time, because it's initial, I'm gonna copy all the levels from previous from the IFC model. So we keep, okay, and after that we don't need IFC anymore, so I'll remove the link, and I'm going to ungroup the binded Revit model. And this duplicate, because it's linking from the other template, I want to remove all unnecessary levels. So this one I can delete, I can leave it to same as level 0 from IFC model. And all the other unnecessary level, for example level 1 is fine, level 2 from the other the other model is not necessary to have it here. Level 2 for here is correct. I would say level 3 and 4. Alright, so these are all now back to let's say it's completely new IFC binded model. So we don't have duplicated here IFC parameters. So in this case, I hope our script gonna work again. So let me open our script. And with Rhino, let's see, we define here, okay, we have to define again the IFC parameter type, so I'll put it IFC Export Edge parameter. So now we have these components all working correctly. So we have here now the same, and we got IFC Tag parameter now. So now it starts to work again. So that was the main reason why we couldn't use it. And now from there, we're going to filter the value of, so this is C1. What I was gonna use here, yeah, exactly. So I'm going to define here again the IFC tag. So you can go here, IFC tag, and I'm going to actually copy and paste this component. I'm gonna delete this one, provide new key here, so we can define here now correct new changed geometry. So that was the main reason. It's really a little bit tricky. I was working around, sorry about that. And I'll save this script another name to end, let's say. And we come down here, there's gonna be same problem where we miss the parameter. So here I have to define IFC special container parameter. Once we can put them, then you see we have all new columns defined, and this scaled one we don't need. I'll turn it off here. Let me save. So we have this completely new column position, and the reason why we don't have here another level of columns, because now we have columns in new position, one of the new level. So I'm gonna copy this script here, and paste, put it into this group. So we have this one, and this column whole script here I'm gonna copy and paste. And what we need, we have to put this output to put new one. So this is the correct one. I'm going to hook it up, insert. Then we should have, so it's funny, the fourth column, yeah, of course we have to provide new one here. So from this one we're gonna filter. So let's see. Alright, so we have all the columns also here, as you can see. This is great, fourth level. And when you compare now with RhinoInside, let me save file, and this new IFC, we generate analytical model immediately from IFC import. Alright, so now I'm going to enable our SOFiSTiK part. we have this now calculation model. Yeah, I just don't want to have windrows and support condition for this example. And I'm gonna make a new SOFiSTiK dot file because I don't want to have overriding the old one. So I'm going to provide new dot data. Let me copy all entire script name. So it's saved, and in SSD all I need to do now, I actually have to change its name, and let's calculate new geometry from Revit, from RhinoInside. And I have to calculate one more time linear analysis because we have new mesh from Revit, from RhinoInside. So we're gonna calculate new geometry now with this linear analysis. Takes a bit of time to calculate. Generate graphical result. So now when we have this geometry in SOFiSTiK, as you can see, you know what? Because the I forgot to hook up the last column to provide mesh geometry for SOFiSTiK. So we back to Grasshopper in RhinoInside. Sorry. We need to provide one more input out of so I'm gonna copy this level 4 columns, and the input for that, the last one, comes out from here. That's for the if there's slanted column, and another script, the last one should come here, and that one I can put into endpoint component here for the last data path. Then let's see so now we have really also structural model of SOFiSTiK here, and let me recalculate the TED file. It is complex workflow, but still it will save a lot of time to redraw the Revit elements with native Revit elements. So we can just open new Revit project file and link IFC, and then this script should work completely normal. I'm gonna have to find out how we can remove this duplicated project parameter. Generally, obviously we can just delete, but maybe we have to delete we have to filter a project parameter name that doesn't have any value. We find out from the string, and that could be interesting topic. I'm gonna research about it, and maybe with RhinoInside we can filter all project parameter which doesn't have value that we can delete from the system. Then previously with the phase option, we could use this IFC link in the same model. So let's have a look now the amended structure. When you look at the dead road, basically it's improved. This amplitude is too high, so it's realistically, one is the realistic deformation scale, and I just make it 50%, 50 times more, so that you can see the result. So this is awesome. Like, everything is adopted to new IFC model, and this is exactly what I wanted to show today. Okay, so that's it for today. Thank you very much for watching it. And I think this workflow, not only for SOFiSTiK, this kind of workflow could be very interesting, because you could link IFC model from any other software, and maybe you need to calculate cost estimation, and for that you could, you know, like filtering the elements and then maybe define or enhance the geometrical, like the precision with Rhino, and you can calculate cost estimation much more precisely what construction company needs. Because previously with Revit and Dynamo you could also do that, but the work is a slow process. So I guess this sort of whole Rhino ecosystem with RhinoInside brings you completely new possibilities for many other aspects. Alright, if you like the video, please subscribe my channel. That way you can sponsor, or let's say support me to continue the research. And please click on the like also, thumbs up. I'm at the moment, this is like really doing it on my own time, but with you, if you support me by just clicking on the subscribe, it's free to do it, and it will be much helpful for me to continue my research. Because I looked at the dashboard, a lot of videos shows the new visitors watching it, but my subscribers watching more or less only 30%. Alright, thank you very much, and I wish you have a nice weekend, and we'll see you again. Thank you. Bye bye.